Hello, this is Mr. Wynn. Today's video will be solving systems of equations. First, make sure you know a system of equations is two or more equations with the same variables, and to solve them, you have to find the ordered pair that satisfies both at the same time. There are three ways to solve them. Graphing, which is not that accurate, it can show you where the general location is and see if there's a solution or not, but it's hard to get the exact point. Substitution is when there's a letter by itself and you plug it in, but rarely do you have equations where a letter is by itself. Then elimination is the best. That's when you force letters to cross each other out by multiplying them and changing them to what you need them to be. So our process will be to use elimination to turn two equations with two variables into one new equation with one variable. Then we solve that for whatever letter it is, then plug that into one of the original two variables to get the second letter. And we'll see that in action in a bit. So first, solve by graphing. Y'all know how to graph these? The first line is -3 for the y-intercept. So I'll put a point at -3. And a slope of +2. So up 2 over 1, up 2 over 1. And so on. Other one's down 2, left 1, down 2, left 1, down 2, left 1. And I connect that. There's my first line. The second one's in standard form, so I'm going to use the intercepts. If I do 2x equals 8, I divide this by 2, I get x equals 4, so the point is 4, 0. If I cover up method, do the other one, 4y equals 8, divide by 2, or 4, sorry, y equals 2, 0, 2. Plot them both and connect it. 4, 0 is right here. 0, 2 is right there. Like that. Alright, and they, as you can see, they do cross about right here. And if that's perfect, it would be 0.2, 1. So that's my answer. So I could check by plugging it into both. If I do 1 for y, I do 2 for x. I simplify the right side, that's 4 minus 3. That equals 1, that's true. I check the bottom one. I'll go on the side over here. 2 times 2 for x plus 4 times 1 for y should be 8. That's 4 plus 4. And 8 equals 8. That's true. So that point makes both equations true at the same time. Now most of the time it's not going to be a perfect point like 2, 1. It might be a decimal or a fraction, and it'll be really hard to see. That's why graphing is not the best way. Also make sure you know about these. You have the words consistent, inconsistent, and dependent and independent. Consistent just means there's a solution. Doesn't matter how many, but there's a solution. So one solution here. Consistent, many solutions. Inconsistent is by itself, means no solutions. Either they're parallel or just they don't cross. Now independent tells you how many. Independent means just one, while dependent means infinite. So if it's no solutions, inconsistent right away. If it's a solution, it's both going to be consistent, then it's going to be dependent for infinite or independent for 1. Second, substitution. If you see a letter by itself, for example, you have a single y right here. I'm going to try to solve for it. So to get that y by itself, I'm going to subtract 2x from both sides. So I get y equals -2x plus 7. Alright, that's going to be my equation. I'm going to use the substitute into the other y. So when I plug that in, I have 5x minus 3. And instead of y, I'm going to substitute that with -2x plus 7 equals 23. And just do my regular algebra. So 5x stays, distribute a negative. So negative times negative is a positive. Negative times a positive is a negative. Then we have combined like terms. Then we add 21 both sides. And then we divide by 11. X is 4. So that's my x. And I need to find y. I plug that into any of the original equations. I'll use the bottom one. Technically, I could use this one right here. So y equals -2 on x was 4 plus 7. That's -8 plus 7, which gives me -1. So my x is 4, y is negative 1. It is a coordinate, so put it together. 4, comma, negative 1. Now, if you plug that into both the original equations, it should be true. And it's a quick check. So 5 times 4 is 20, minus 3 times negative 1 is positive 3. That should be 23. Well, 23 does equal 23. I try the other side, the bottom. 2 times 4 is 8, plus negative 1 should be 7. 8 minus 1 is 7. That's also true. Actually, that's substitution. But again, not often we have a single letter by itself. There's going to be a number or fraction in front of it. So here's elimination. For elimination, you want to make the numbers in front of the letter you want to get rid of match, and make sure you have different signs. One has to be positive, one has to be negative. So here, you can choose x or y. I'm going to choose to get x deleted. To change x, I have to figure out what does 4 and 5 jump onto. What's the least common multiple, LCM? So to do that, I'm going to multiply the top one by 5. So that'll give me 20x plus 30y equals negative 80. I'll multiply the bottom one by, instead of 4, I'm going to do negative 4 because I'll make the signs opposite. So that'll give me negative 20x minus 12y equals positive 8. So as you can see, we have two brand new equations. We have 20x plus 30y equals negative 80. Negative 20x minus 12y equals 8. The nice thing about elimination is all you do is add straight downwards. Keep the sign normal. So 20x minus 20x is 0. They cancel out. Positive 30y minus 12y is positive 18y. Negative 80 plus 8 is negative 72. And I solve that. All I do is division. One step. Y equals negative 4. Once you have y, we got to find x. Pick one of the original equations, or anything you've done so far, and plug it in. I'll use that bottom one. So 5x plus 3, y was negative 4, equals negative 2. 5x minus 12 equals negative 2. Add 12 both sides. 5x equals positive 10. Divide by 5. X equals 2. So I have my x and my y. I'm going to write as a coordinate. That's the answer. If I plug both of them in to both blue equations, they'll both turn out true. Alright, here we had to choose either substitution or elimination. There is no letter by itself, so can't use substitution at all. I'm going to do elimination, and I noticed that the 3y and the 9y, that's easy. I can multiply this first one by negative 3. So if I distribute that, that's really negative 15x minus 9y equals negative 156. And using that equation, there we have the matching numbers. One's positive, one's negative. I'm going to add straight down. So negative 15x plus 15x, well, that gives me 0. Negative 9y plus 9y, that also gives me 0. Negative 156 plus 54 gives me negative 102. 0 equals negative 102. Well, that's false no matter how hard you try. If it's false, this is going to be no solution. There's no way these are ever going to cross. So you could get no solution here. In this case, that would be inconsistent. Alright, then this last one, solve using substitution or elimination. I see x's already have one positive, one negative. I can make them match. I'll multiply this first one by positive 2. So that'll give me 4x plus 6y equals 30. If I add straight down, 4x minus 4x is 0. 6y minus 6y is also 0. 30 minus 30 is also 0. 0 equals 0. That's true. If it's going to be true, it's going to have infinite solutions. You could say infinitely many solutions. So that would be consistent and dependent. Alright, here's the practice problem. Try it. Use either one, substitution or elimination, although I recommend elimination. You should get the answer -1 for x, 6 for y. Alright, thanks for watching. See you in class.